All right, this video is for number 7 on page 40. So, Renata Gas is driving through town at 25 meters per second and begins to accelerate at a constant rate of negative 1.0 meters per second. So what does that mean? That means she's slowing down. She's decelerating. Eventually, Renata comes to a complete stop. Represent Renata's accelerated motion by sketching a velocity time graph. Use kinematic equations to calculate the distance which Renata travels while decelerating. So, first, I prefer my graph to be accurate, so I'm going to actually do the algebra first in order to understand what's happening. So, as always, we first start by setting up our problem. So, I've got s equals xi plus vit plus 1 half at squared, and a equals vf minus vi over t. And my variables, same with me, s, xi, vi, vf, a, and t. So, let's draw a quick picture just so we can understand what's happening, get a good frame of reference. That's a car. So, she starts at 25 meters per second, but she's decelerating at negative 1 meters per second. So, I'm going to say she starts at 0 meters, and everything this way is positive. Great. So, xi, 0 meters. Vi, 25 meters per second. How do I know it's 25 meters per second? How do I know that's not the final velocity? Well, because it tells me she starts at 25 meters per second, and she slows to a complete stop. So I know that final velocity has to be 0, because that's what stop means. So 0 meters per second. And then acceleration is given to me. I know it's acceleration because it is meters per second squared, and that's our units for acceleration. So, negative 1.0. Now you gotta make sure you keep that negative 1 there. The integers will change it. And then, time and displacement. So, let's see, I'm not given time, so I'm gonna have to figure those out. Well, I can use my acceleration equation to determine time. That's nice and simple. We've already done that. So, A equals Vf minus Vi over T. If I want to solve for T, I just have to switch T and A, because multiplying both sides by T is going to result in AT, and then dividing both sides by A going to get rid of the A. Simple enough. So T equals Vf minus Vi over A. So Vf is 0 minus 25 meters per second over negative 1. Now, the key thing to remember here is Vf minus Vi. This will result in a negative number on top. Divided by a negative number, that's going to be a positive number, which will mean my time is positive. Let's just go through and do that real quick. 0 minus 25 is negative 25, divided by negative 1 is positive 25. It's got to be a positive number because it's time. It wouldn't make sense otherwise. So, if you get a negative number for your time when you're doing an acceleration equation, you probably have your velocity final and your velocity initial flipped. That's a good thing to check. So now I've got my time. I can solve for my s. So s equals xi plus vit plus 1 half at squared. So substitute my xi, that's going to be 0, plus vi, it's going to be 25. Substitute in my t, which is also going to be 25. I saw some people make the mistake of thinking, oh, 25, okay, I got it in there, great. And moving on. Make sure you put your variables in. 1 half a negative 1 times t, 25, squared. Now, let's think about this for a second. Renata is driving forward and slowing down until she comes to a stop. All of my motion is still going forward. Everything should be positive. My s should end up being positive, just using the logic of what's really happening. So, 0 drops out. 25 times 25, and I don't want to do it in my head. It's going to be 625 plus, and then 1 half times negative 1 times 25 squared. It's going to be negative 312.5. Now, this 1 doesn't really do much. But because it's negative, it causes this whole thing to be negative. Because if we think about that, yeah, that's going to subtract from my total distance because I'm decelerating. That makes sense. So 625 plus a negative 312.5. And wouldn't you guess it? I'm betting it's going to be 312.5. Oh, would you look at that? 312.5 is my final displacement. So, remember, put it in, box it, or else I'm not going to see it, probably won't be valid. So now let's sketch a quick graph just to make sure. And it was velocity or time. So my velocity starts at 25, so I'm going to start up here, 25. And it goes to 0 after 25 seconds. So these are seconds, these are meters, so my meters are going to go to 0 at 25 seconds. My velocity is going to look like that. Just a nice straight curve going down to 0. If I were to graph the displacement, well, then I'm starting at 0, and I'm slowing down. So I'm starting at a speed like that, and then I'm going to slow down until at 25 seconds, I've come to a complete stop. And then I've stopped. For the rest of the time, I'm stopped. Does that make sense? Yeah? Great.